All right, in this lesson, we are going to be learning how you can solve equations that have variables that are in the exponents, and we're going to be using logarithms to do that. Before we start, however, I just want to look at some different ways that we can write numbers. This is some information we're going to need later in the lesson. Like 4, you could write as 4 to the first power. Or you could write 4 by using a base of 2 and saying it's 2 squared. The number 16, we could write as 16 to the first power. Or we could write with a base of 4, 4 squared. Or we could even write it with a base of 2, 2 to the fourth equals 16. Let's look at 8 and think about some ways we could write that with a different base. We could write it, well, with the same base of 8 to the 1, with a different base of 2 to the third. Or we could even write it with a base of 64, because the square root of 64 is 8, so we would write it to the 1/2 power, because remember, that means the square root of 64. 64, some other ways we could write that besides 64 to the first power would be 8 to the second is 64, or 4 to the third, or even 2 to the sixth power. And then 1/16. Now, if we look at 16, 16 can be written with a base of 2, right? Because 2 to the fourth is 16. So if we write 2 to the negative 4, that would be equal to 1/16. Because remember, 2 to the negative 4 is equal to 1 over 2 to the positive 4, which would be 1 over 16. Or we could write it as 4, and then 4 squared is 16, so it would be 4 to the negative 2. Because again, 4 to the negative 2 equals 1 over 4 to the positive 2, which is 1/16. All right, let's move into the main part of the lesson here. So what is a logarithm? Well, a logarithm of y with base b is denoted by log base b of y, and it is defined as the following. So b to the x equals y if and only if the log base b of y equals x. So a logarithm is really an exponent that makes a base equal to y. So if we have a logarithm, that's saying that is the exponent that makes a base equal to y. So let's look at how we can do that. First, what we're going to do is understand that form, and we're going to write, be able to write expressions in exponential form and logarithmic form. So if you say log base 2 of 8 equals 3, what that's saying is the exponent on the base of 2 that makes it equal to 8. So the exponent would be 3. So to write it in the other form, I always make kind of a backward C here. You would write 2 to the third equals 8. And that's a true statement. So 3 is that exponent that you would put on the base of 2 to get 8. So here, the log means the exponent that we put on the base of 4, which if we want to end up with a 1, it would have to be an exponent of 0. So 4 to the 0 equals 1. So here, the exponent, the log, the exponent on the base of 12. So 12 to the first power is equal to 12. The log, base 1/4. So the base is 1/4. And the exponent would be a negative 1, and that would give us 4. Because if we distribute negative 1 through 1 to any power is 1, and then we have 4 to the negative 1, well, the 4 would have to, we'd have to write the reciprocal of 1 over 4. That would be 4 over 1 and make the exponent positive. So that does indeed equal 4. Now here are some problems. It says rewrite the equation in exponential form. So the base is 3. So 3 to the fourth power equals 81. Here's the base. 7 to the first power is equal to 7. 14 to the 0 power equals 1, and that's a true statement. 1/2 to the negative 5th power equals 32. So using the definition of a logarithm, we're able to convert back and forth between log form and exponential form. And eventually we're going to use that to solve equations. So here are some more problems. It says rewrite each equation in logarithmic form. So here we have a power. The base of it is u. So u to the negative 14th is equal to v. So if we're going to write it in log form, we write log, and the base is u, and the base u, log means the exponent we want on the base u that will help us end up with v. And so that would equal negative 14. We're using the same backward c, so base u of v equals negative 14. U of v equals negative 14. So log base 64 of 8 is equal to 1/2. So the exponent you would put on the base of 64 to get 8 would be 1/2. So 64, the exponent we would want would be 1/2. That would give us 8, which is true because the square root of 64 equals 8. All right, so now it says evaluate the logarithm. What it's saying is we want to find out what would that exponent be. So we're going to say that this is equal to x. So log base 4 of 64 equals x. And then to solve problems that either have a variable for an exponent or where we're looking for what the log is, we can write it in the other form. So if we're in log form, write it in exponential form. So 4 to the x equals 64. 4 to the x equals 64. And then you can look at your root sheets or just figure out 4 to what power gives you 64. Well, that would be 4 to the third is equal to 64. So x must equal 3. So here's another problem. So this is in log form. Okay, log base 5 of 2/10 is equal to what? So we'll write it in the other form. 5 to the x equals 0.2. Well, if you look at your root sheet, you don't see any 0.2s on there. However, remember, 0.2 actually means 2/10. And if we reduce that, that's 1/5. So let's rewrite that. Now we see here we have a base of 5, and 1/5 could be written this way. Let me see here. 5, let's just keep it this way. I'm going to back up just a hair. There's another way to do this problem, but we'll stick with what we were doing in the first one here. So what exponent would x be in order to make 1/5? Well, if we put a -1 right here, that would be 5 or 1 over 5 to the positive 1. So x must equal a -1 because 5 to the -1 equals 1 over 5 to the positive 1. The problem's giving me fits today. 1 over 5 to the positive 1. Okay, let's do another one. So we're going to set this equal to x. 1/5 to the x power equals 125. So if you think about what exponent would give us 125. Now the 5's in the denominator, so we are going to want to have a negative exponent because then that would give us the reciprocal. And think about 5 to what power would give us 125? Well, that would be to the third. So x would have to equal a -3. So just watch. So if we have 1 over 5 to the -3, that would be a 5 to the positive 3, which is 125. See how that works? Here's another one. I'm a little short on room here. So 36 to the x power is equal to 6. So if you think about how do we go from 36 to 6, well, we'd have to take the square root of 36. So the exponent that means take the square root is 1/2. Because 36 to the 1/2 means the square root of 36, which equals 6. So x equals 1/2. Now we're going to do a worksheet just to practice writing the different forms, log form and exponential form. And so the first problem says log base 6 of 36 equals 2, and we're supposed to rewrite that in exponential form. Well, the base is 6, so you write 6 to the second equals 36. Just like that. Let me rewrite that. My pen went a little crazy there. So 6 to the second equals 36. 6 to the second equals 36. Here we'll do another one. So the base here in this one, number 9, is u, and then u to the v power. It equals 15 over 16. So u to the v equals 15 over 16. Number 5 says rewrite each equation in logarithmic form. So now we have an exponential form. We're switching it to log form. So the base of the exponent is 64. So we write log base 64 of 8 is equal to 1/2. This next one, we'll write log base u of v equals -14. All right, another property we need to understand about logs, and to help us understand that, we're going to look back at another chapter where we learned about inverses of functions. And we did a worksheet where you had a function and its inverse, and like for example, you found f of f inverse of 3. And when you solve that out, you realize that the answer was 3. And so from that, remember we figured out that f of f inverse of x was always equal to x. So this property will carry through with logs. Let me go on and show you that. So if you have log base b of b to the x, it will equal x. All right, or if you have b to the log base b of x, it will equal x. And so basically what's happening here, it seems like, is that this undoes this and your answer is the x. So b to the log b, their inverse functions, your answer is this. So now, just a little note here on this problem, it doesn't have a base right here, and whenever you see that happen, it's the common log, and it's base 10, so you can write that in. And so here, we'll notice that we have 10 log base 10, so when the bases are the same, your answer is just whatever this is right here, your exponent is, it's 4. Now, if you look at this one, you might say, well, we don't have the same bases, but if you think about 25, that can be written as 5 squared. And then there's still an x in the exponent. So now we have log base 5, and here's a base 5, so they kind of undo each other, and your answer is 2x. Here's another one, base 8, that answer is just x. Base 7, that answer is minus 3x. 64, now that's a different base than 2, but we can write 64 with a base of 2. So we're going to redo that so that we can use that strategy. So that would be 2 to the 6th power. And then you still have the x there. Now the bases are the same, so they undo each other. They're inverse functions, so you just have 6x as your answer. And like I said earlier, the common logarithm is a logarithm with base 10. So log base 10 of x, since it's the most common, it can be denoted as just log of x. And this is what is programmed into your calculator when you use the log button. So you can type in the log of 8 in your calculator. So you just hit the log button and then 8. And you should get approximately 0.9. The log of 14, if you type that into your calculator, you just hit the log button and then type 14. And you get 1.15 approximately. Now, because the calculator only has your common log, you can't type in something like this example right here that's log base 2 of 6. But there is a change of base formula, and we're going to use it. It's right here. So the log base c of a can be found on your calculator by using the common log of a, so the log of the larger typed number over the log of c, which is the log of your base. So in your calculator, like if you want to find the log base 2 of 6, you type in log of 6 divided by log of 2. And just some notes here when you type it into your calculator. If you're using the app or the Texas Instruments TI-30X2S, you would type in log 6, and then you'd have to put the other parenthesis, and then hit divided by log 2. And you should get 2.58. So it's approximately 2.58, and I will put 5. I'll go 3 places. Now, just so you understand this, if we were to write this in the other form, exponential form, 2 to the 2.585, that would be just about equal to 6. And I say just about because we did round this right here. So for this one, log base 3 of 9, you type in log of 9. So log of 9 divided by the log of base 3. That. And so that gives you log of 9 divided by the log of 3. Which is 2. The next one, you type in log 8 divided by log 3. And that will give you your answer. All right, that's all for lesson 7.3. Thanks for watching.